Okay, hi Addy. Welcome to lesson number 40. Today's lesson is going to be super fun, and the first thing that you're going to do is start out with 64 multiplication facts. So that's going to be fun. And then the lesson is great because it goes over using 0 as a placeholder, which is something that's super important for you to know how to do. And then it's going to go over circle graphs, which is basically another way of saying pie graphs and how you interpret information from pie graphs. Okay, so that's going to be super fun. I hope you enjoy this lesson. Get ready to do your multiplication facts, okay? Ready, set, go. Okay, hi there, Addy. Welcome to lesson number 40, math lesson. You should have done your 64 multiplication facts by now, so good job doing that. And this lesson is super fun because it goes over just using 0 as a placeholder. So that's a very important thing that you need to learn so that you get these questions right, because I know that you actually struggle with this, so I want you to pay lots and lots of attention to this lesson, because sometimes it's hard to divide by 100, times by 100, do all these things. So you got to get really comfortable using 0 as a placeholder. That's basically what you're doing even when you multiply by 100. You're just basically multiplying by 1. And then the zeros are placeholders, right? So it's actually 1, but it's in the hundredths place. So I want you to start thinking of it. Alrighty, sorry about that interruption, Addy, but we are going to move right along. So first I have a little joke for you. What did the 0 say to the 8? Nice belt. Get it? Get it? Because if you put a belt on a 0. Okay, anyway, let's move on to mental math. And the first thing that we're going to do for mental math is we're going to count by 8s from 8 to 96. Okay, so as we do this, I want you to be thinking about how we're going to keep these numbers straight. So we're going to think about what is 8 times 1 times 2 times 3, and then that'll help you to count by 8s, okay? So let's try it. We'll start with 8, 16, 24, 32, 40, 48, 56, 64. What comes next? It's going to be 70 something, right? The other way you can do it is just 64 plus 8. So 72, 80, 88, 96. Okay, I think we got them all. Phew, now we can breathe in and out. Okay, let's move on to the rest of mental math. Now, this is for you to do in your head. We're going to start with 4 times 800 plus 4 times 25. Write your answer. How about B? 1500 plus 750. Write your answer. C is going to be 74 minus 39. D is going to be $8.25 minus $1.50. These are getting pretty tricky. What about E? We're going to double 240. F is 480 divided by 10. G. Okay, for this one, here's what we're going to do. We're going to start with the number 4 times 4. Then subtract 1. Divide by 5. Multiply by 6. Add 2. Multiply by 2. Add 2. And then divide by 6. If you need me to repeat that, go ahead and rewind, but I'm going to move on to problem solving. Now, problem solving, you might remember that we did this together, but guess what? I'm not going to give you the answer this time. I'm going to have you do it all by yourself and see if you can remember what we did before, okay? Sorry if that's kind of mean. I kind of feel a little like Nelson there. Okay, new concept. The new concept goes over using 0 as a placeholder. So basically, when we are subtracting and we're multiplying and we're dividing decimal numbers, sometimes we see lots of zeros. And sometimes there's not a 0 when it seems like there should be, like right here, for example. So, for example, if we're going to subtract 0.5 minus 0.32, we have to line up the decimals. And it makes more sense when we're lining up the decimals that there should be a 0 right here. Whoops, I didn't realize that was going to make a square. That's a funny thing. Okay, we will try that again. I'll make a 0. Alrighty, now we're going to go over this problem in a minute, so I won't solve it right now, but just wanted to show you that you can add a 0 in that location and it does not change the value of this number at all, okay? Now, here's another one, 0.2 times 0.3. Now, when you solve this problem, you're going to get, because you already know that 3 times 2 is 6, but there's actually a space, a decimal, and another space because you have to move the decimal 2 spots over. 1, 2, so 1, 2. So if you move the decimal 2 spots over, that leaves some spaces for some zeros. So you have to fill those in with zeros, okay? So 0 is working as a placeholder in that situation because we know that 3 times 2 is 6, but you have to add some extra zeros there. Now, what about this one? If you have, basically, think of this as 12 divided by 3 is 4. But because of these two decimals, you have to add another 0 right here to have that be the correct answer. So here's how we're going to do these problems. We're going to go through them again. Example 1 is subtract 0.5 minus 0.32. So you remember that to do this, we have to line up the decimals. So I'm going to write 0.5, and then I'm going to write 0.32. And I'm doing it like that because I want the decimals to line up. So that's important. It's also important to have a negative sign. And because there's a space here, I want to make sure that that space is filled with something because it doesn't make sense to have an empty space and it makes it harder to subtract. So I'm going to put a 0 there. And then once the 0 is there, it makes it easier to subtract because we're going to do 0 minus 2, which of course you can't do. So we're going to have to borrow a 1. So we change that to a 4 and put the 1 there. Now we have 10 minus 2, and 10 minus 2 is 8. Now we're going to go to the 10ths place, and we're going to have 4 minus 3. So 4 minus 3 is 1. Then, because of these decimals, I'm going to bring down the decimals, and I'm going to put it right there. And then we have just 0 minus 0, which is 0, and we're going to put that there. Okay? All right, so I think you understand how to do that, Addy. We're going to move on to example 2, which says subtract 3 minus 0.4. So the first thing I'm going to do is line up the decimals, but there is no decimal point with the 3. So we're going to make that whole number a decimal. So I'm going to put a decimal right after it because 3 is in the ones place. And then that leaves a space here where we need to put an extra 0. So I'm going to put 3.0. And you can tell that that does not change the value of the number 3. It's just writing it in a different way. Now I'm going to subtract 0.4. Well, I'm going to line up the decimals a little better. There we go, 0.4. Now the decimals are lined up, so I can subtract straight down. Another reason we had to add this 0 here is because you can't subtract 4 from nothing. So we do have 0 here, so now it's 0 minus 4, which of course we can't do like that, so we have to borrow a 1. So let's turn that into a 2, make that a 10. So now we're going to say 10 minus 4, and that's going to be 6. And over here in the ones place, we have 2 minus 0, which is going to be 2, and I'm going to bring down that decimal straight down. So the answer is 2.6. Okay, now when we multiply decimals, we might need to add a 0 or even more than 1 0 between the multiplication answer and the decimal point to hold the other digits in their proper places. So I'll show you what I mean by that because that's a lot to think about. So let's just do the problem. We're going to multiply 0.2 times 0.3. Now remember, when you multiply, you do not need to line up the decimals. They just happen to line up in this situation. So the first thing we're going to do is 3 times 2. So 3 times 2 is 6. 3 times 0 is 0. Okay. Now, so that's the answer that I'm left with. I don't really have to multiply this 0 by anything because the answer is just going to be a bunch of extra zeros. So now I have to figure out where the decimal goes. So let's count over how many spots we need to move it. So here is 1 spot, 2 spots. So we're going to go 1, 2. And now I know that the decimal goes here, okay? But 0.06, usually we add a 0 in front of the decimal. If we had only done 3 times 2 is 6, and that's all we had for an answer, we would have had to add this 0 too. But I went ahead and multiplied this 0 out, so that's why we ended up with that 0 there. But either way, you have to put the decimal over 1, 2, 1, 2. So that tells you how many zeros you need to add. So there you go. So now we fill in basically the empty spaces so that 6 ends up in the 100th place because you have to move the decimal 2 spots. All right, let's move on to example 4. It says use digits to write the decimal number 12,000. So they want us to write out this number. So because there's a 12 here, I'm just going to write down the number 12. Now, we also have this, thousandths. So that tells us that there must be 3 places to the right of the decimal. So if there are 3 places, there's going to be 1, 2, 3 places, and then the decimal goes there, okay? So there's 3 spaces past the decimal point because of this word thousandths right there. So any empty space, I have to fill it with a 0. So now I know that the answer is 0.012. You could also put a 0 in front of the decimal right there. That doesn't change the answer. So this is the more correct answer, 0.012. Okay? All right, now we're going to go on to talk about another concept, which is circle graphs. And circle graphs are also called pie graphs. So that's why I put this little GIF of Homer Simpson. Oh, I didn't even notice that last part where his dog came and ate it. So somebody set a pie trap because, you know, he loves to eat goodies like pies. And he got caught in the trap. And then while he's up there swinging, his little dog came by. That's kind of sad, actually. Now what's he going to do? Because he's just hanging there. I don't even remember seeing that episode. Do you? Anyway, let's move on to pie graphs or circle graphs. All right, so the next example uses a circle graph to display the information. So it'll kind of explain it as we go. So I'm going to go on to example 5, which is on page 210. And this is a funny example because the guy in the story, his name is Brett. And that's your uncle's name. And it's kind of an unusual name. Not a lot of people have that name. So that's kind of cool. So here's the pie graph, and it basically says that Brett collected information from people in his neighborhood about their pets. So then he displayed the information about the number of pets using this circle graph. And it says, use the graph to answer the following questions. So a graph like this shows all of the pets as if they were like pieces of a pie. And when you divide a pie graph, you actually divide it in chunks that look like you're taking pieces of a pie. And you might notice that this would be the equivalent of half the pie. And so it does cram a lot of information into a small space. That's why you can do it that way, because you'll immediately know the relationship. If the circle is all of the pets, then you can know how many dogs are there compared to all of the pets, how many cats are there compared to all of the pets, or even compared to dogs or birds or each other, right? So let's just go through the questions. And the first one says, how many pets are represented in the graph? So how many total pets are there? So I rewrote the question to reflect how many total pets are there. So basically what we do is we look at these numbers. Even if they had only given us one number, you could figure out all of these other numbers because you would say, well, this is half the total. So we don't even need these numbers. So if we have the number of dogs and it's 16, then we know that 16 takes up half of the total number of pets. Then the total number is going to be 16 times 2, or it's going to be what? What is 16 times 2? going to be 32. So there are 32 total pets. And then the next question is, what fraction are birds? So it wants to know how many birds are there compared to the whole. So they do use the word fraction, so we're going to put our answer in the form of a fraction. And the fraction is going to be birds on top divided by total, because it says total pets. Because it says what fraction of the pets are birds. So the numerator is birds and the denominator is total pets, because that's what they're asking for, the fraction of the total pets that are birds. So we already know that there are 32 total pets because we figured that out with the first one. So I'm going to write 32. And then how many birds are there? Well, you just look at the graph and you can see that there's a number 4 there. And you could also see, what if it was asking what percent this was? And I think you can tell that half of the total is dogs, a fourth of the total is cats. But if this were a pie and you ate this much pie, you would be eating an eighth of a pie because it's half of a fourth. So it would be an eighth of a pie. But anyway, they're not asking that. They're asking a much easier question, is to write it in the form of a fraction. So it's 4 over 32 is the answer. But 4 over 32 can be reduced because 4 goes into 32. And it goes into 32 8 times because 4 times 8 is 32. So it's going to be 1/8 is going to be the answer. All right, so you're going to want to remember to reduce the fractions. The last question is, what percent of the pets are dogs? So we already kind of figured that out. If we look at the pie chart, and this time it doesn't want a fraction, it wants a percent. So if you ate this much of the pie, what percent of it would you eat? And I think you would notice that you would eat half of the pie, and half of the pie is the same as, well, the way to figure it out is what percent over 100 is half the pie. And half of 100 is 50%. Because remember, a percentage is basically just a fraction over 100. Alrighty, so that's really cool. Circle graphs are kind of fun. So I hope you enjoyed this lesson, and now it's time for your lesson practice. So good luck with the rest of your lesson, Addy, and have fun. I can't wait to see what you do with this. Love ya. Bye.